Now we will look at dynamic images and viewing the tracer kinetics within those images and capturing movies of that. Again, we start in the View tool. If we move back to the DB load page, we can now select RAT3, where we see we have a dynamic FDG brain image. There is a single series available, which is the dynamic whole body PET. We can add that series to the list for loading, and if we open it, then again we will jump to the View tab. Naturally, it takes a little longer than for the static images as we have many time frames. We maintain the previous display, so we should switch back to the orthogonal planes view. This time we can right click in the image display. We have an option for changing the layout. Here we can select orthogonal and we move immediately back to the orthogonal display. Also note that there are a list of keyboard shortcuts available, so you see that we have keyboard shortcuts available for the layouts as well. In this case, the image does not look that attractive at the moment, so we need to improve that and understand what's going on. First of all, we can see that the color table has become very compressed from the last data we were working on. So we can set the upper threshold of the color table to 800. We'll check exactly what units that is a little later. Using the T icon below the color bar, we can bring back our cursor and our anatomical labels, and then we can explore the data again as usual. And the particular time frame that's displayed doesn't contain particularly high uptake, doesn't show us anything very clearly. Now, as well as the slice selection slider that we've seen in the last exercises, we have a second slider available, and this is the frame slider for these dynamic series. So if we advance that slider, we see the tracer uptake in the image display changing over time, and for an FDG example like this, typically the last time frame will give us the most stable point of uptake. We see a certain amount of activity in the brain, in the Harderian glands around the eyes. We also saw high uptake in the myocardium, as expected for certain imaging protocols, and we see some activity in the kidney areas as well. So as well as viewing this change of the tracer activity over time using the frame slider, we can do this as a movie. So the third tab in our image control tabs in the top right is the movie tab. At the moment, slices is selected, so we can change to time frames, and as a first example we can start a movie playing through the time frames by clicking on the white arrow. Then in the image display, in all three planes, we see the evolution of the tracer uptake over time. We can adjust the speed of the movie using the black arrows in the lower right of the movie tab. We can slow down the movie and see the tracer uptake building up in the brain in this particular case. And if we want to capture that movie for presentation, then we can activate the film strip icon on the frame on the movie tab. The mode changes from continuous play to a single shot through. We can select exactly which time frames are captured, and then the next time we start the movie, we get a save video dialog. As you can see, we have a choice between a QuickTime movie, or we can use an animated GIF. The GIF can be quite helpful for embedding into PowerPoint and can be set to be a continuous loop. We can adjust the frame rate depending on experience and how we want the movie to look in our presentation, and we can choose whether we only want one of the planes displayed or the full display. Then when we start the movie, we run through the frames that were included, and we have the chance to save that GIF image either to the database, which is shown by default, or we can select Save to File System, which means we can more easily drag that GIF into PowerPoint. There we could select an appropriate folder. So I can take the USB drive where we have the PMOD trial folder, and then within the PMOD data folder I could make a new folder for my examples. And here we can save the RAT3 GIF. So that's a movie captured, ready for use in presentation. In the last exercise we saw the multi-slice layout. Naturally we might also want a multi-frame layout. So again, if we go back to the Layout tab, instead of orthogonal planes we can select the Y plane, where at the moment we see again a 1:1 layout. In this case, instead of the default options, we could select the R/N layout and enter our own definition of the display, 1 row with 8 columns. And then instead of showing a different slice in each of those individual images shown in the display, we can switch to time, and now we see the same slice over time across that row in our display. Since we only have 8 images displayed and we have 16 time frames, we may also want to skip time frames. So as we did for the slice jumping, we can enter a value of 2 in the frame steps. Then we can use the slider to fill up our display, and we can then see the evolution of the tracer uptake over the time from pretty much injection through to the final time frame. And then again, such a display can be captured also as scientific output. So we can include a vertical color bar with annotated units, and then again we would have an interesting image with its own color bar that could be captured and then potentially pasted into our PowerPoint presentation.